Hello, and welcome to the Scientific Adventures of Beardman. Today we're going to be looking at a skill on positivephysics.org in the Science and Math Toolkit, which is often Unit 0. You can see I've got it Unit 1 in my class. And we're looking at the skill extrapolating data. This skill gets used throughout the year in positive physics as you go to units like, I think this one is forces and introduction to forces, and when you do the inquiry. The inquiry almost always has some sort of a simulation. This one I've got opened here. And this simulation allows you to answer these questions. And most of them are straightforward until you get to the bottom here. And then you'll see problems that say, problems below can be answered using extrapolation or interpolation and have a 5% tolerance to allow for estimation. We recommend using Desmos graphing application to create graphs when necessary. In this skill, if this is on a test you have, you'll want to use the graphing calculator to do that. And to do that, Jack, who created Positive Physics, has a wonderful video that teaches you how to do that. So I'd recommend using that. I'll link it here, and that'll help you if you need help with that. But in my class, I like my students to look and recognize patterns, not just plug into a graph and get an answer, but look and recognize patterns. And so that's what I'm going to show you how to do. It often leads to a couple wrong answers. That's why I wouldn't recommend this for a place where you're being tested on it. But most of the inquiries are just used to get a feel for the subject, and I think the estimating is very powerful for that. So let's step right into it. So you'll notice we have X values changing while Y values are changing. If you've already looked at proportionalities, if you haven't, take a look at some of these videos I'm linking here, and you'll see how to recognize the proportionalities that I'm going to talk about. So first of all, if we look at changing here, we can see that we've got 90 to 193. Now that's not an exact easy factor. You could get out a calculator and figure out exactly what you have to multiply 90 by to get to 193. I'm just going to estimate. 90 times 2 is 180. That's pretty close. So we have a little bit more than times 2 here. And 44 times 4 would take you to what, 176, 177, which is pretty close to this. So a little more than times 4. So we have a little more than times 2, gives us a little more than times 4. Well, that's going to be something close to a quadratic relationship. Okay, so if we look at the next number here, times 2, 134 times 2 would be 168. About 100 times 4, because we're quadratic here, so instead of times 2, we do times the square of 2. Times 4 would give you 400. So if 268 gives us 400, the 225 is probably closer to the 193 than to 268. So it's probably going to be closer to 200 than to 400. So we probably want to collect something a little bit less than 300. We can try a few things here. We can try 250, that's less than 300. We got that wrong, so let's try something else in that ballpark. We'll try 275, and it turns out to be 276. Remember, anywhere within the 5% tolerance would give you credit for getting this right. So we now have realized we were in the ballpark, and that meant we understood the concept of the kind of change that was taking place here. So let's take a look at that quickly here in the things you'll be doing all year where you have a question. Now, first of all, let me just point out that this concept builder has masses that you can see here. It's got 1, 2, 3, 4, 5, 6 different masses that you can use. And you can use forces of 0 to 500 newtons. Now, this particular question has you use a 60 kilogram object and a 500 Newton force. Well, we can do a 500 Newton force, but you'll notice there's no 60 kilogram option. There aren't two things that add up to 60. Like we don't have two 30s or a 40 and a 20, okay? Or like 120 we could do, but we can't do 60. So what we'll have to do is get a couple of values, okay? And because there's friction, this doesn't work super nicely unless you're much more advanced, and this should be done at the beginning of the forces unit, so you'll have to look for patterns, okay? So if we take the 50 kilogram box, and we see that the 50 kilogram box gives us an acceleration of 8.1. So 8.1 is what we'd get for a 50 kilogram box. So a 50 kilogram box would give us 8.1 as an answer. Then if we go ahead and switch to a 40 kilogram object, that would give us a 10.6. So we've got 10.6 for 40. We've got 8.1 for 50. So we can see as the mass is getting bigger, our acceleration is getting smaller. Okay? Those of you who know what we're talking about already, frictional force changed from 75 for a 45 to 94 for a 50. So we see some changing in that friction. That makes it difficult for people to just plain calculate. Okay, so we got 10.6 here, 8.1 here. If we jump all the way to an 80 kilogram, we know that we'd have 4.3. So it has to be between 8.1 and 4.3. So we could certainly start guessing here. It's got to be less than 8, because we know that as the mass goes up, the acceleration goes down. So since 60 is more than 50, then we have to be less than 8.1. So we could start guessing in here. So let's guess not 70, let's guess 7. Okay, that's not right. And it should be closer to the 50 value to the 8. So 7, let's try 6.5. And look at that, 6.5 worked. We were in the ballpark of where we thought the answer was. That meant we had a good basic understanding, and we're ready to move on to learning how to actually calculate these things in the rest of the Introduction to Forces unit. This will apply to every unit that has an inquiry. There will almost always be some questions you have to extrapolate. You're welcome to go back to the graphing calculator like Jack shows you in the videos. But if you don't want to do that, or your teacher doesn't want you to do that, then go ahead, like in my class, and just use the estimating technique that I just showed you. Have fun learning physics. I hope you're enjoying positive physics and the scientific adventures of Beardman. We'll catch you the next time. Keep learning physics.